Today we're going to take a look at the final type of drawing that we're going to do, and it's multi-view sketching. So we know that multi means many, and typically we'll have many views to describe the object. For example, this object right here we see an isometric view, and we've identified a front area over here, a right side, and a top. Now if we want to accurately put dimensions on this object, what we're going to have to do is create a two-dimensional front view, and you can see that this view right here sort of becomes clear that we're looking at it from the point of view of this arrow here. And we're going to have a side view here, so that's looking at it from this point here. Hopefully you can see that. And for the top view, we're looking straight down. And the key thing about this is that on all these two-dimensional drawings, we can put dimensions that are accurate, whereas when we're dealing with the isometric view, it's not clear how we're going to dimension the edges and things like that. Okay, a multi-view drawing. Again, it shows a two-dimensional view. That's the key thing here. Everything we've done so far has been three-dimensional views. Creates a two-dimensional views of a three-dimensional object. Okay, and this is really important. When combined with the dimensions, it serves as the main form of communication between designers, which has kind of been us so far, and manufacturers. So if person A designs something, that person will make a multi-view drawing that's dimensioned, give it to person B, who may operate the 3D printer or the milling machine, the computer numerical control milling machine, or some other machine. And this person will be able to know the dimensions exactly as they should be. Here's an example of a multi-view sketch. And we've got the front and the right side. Looking straight down, we'll see the top. And if we were to go to the left side, it would look like that. And again, we're looking in a particular direction. We make a 2D sketch, as opposed to our friend the isometric or perspective here, which is a three-dimensional view. Okay, here's a good example of a multi-view drawing. So we see that the isometric is here, and you can trace out, say over here, that's going to be the front view corresponding to right here. And then if we were to go to, say, this view here, corresponds to looking at this side right here. So you can see that this part here corresponds to here, and then these parts here correspond to here and here, and this part here corresponds to the part in there. You can't really see in there, and I think I missed that part corresponding to over there. Okay, then if we look straight down, we're going to see we're going to see two rectangles there. We're going to see another rectangle here. There's going to be an edge there, so that's going to appear as an edge right here. That's going to appear as a line, and so that corresponds to this, and this, and this. And then over here, this part corresponds to this. And again, the key thing here is that these are all 2D drawings that allow us to put dimensions here that correspond to the actual dimensions. So multi-view drawing, all three-dimensional objects have width, height, and depth. So the width is associated with an object's side-to-side dimension. So this is the width here of this object. It's the side dimension here. Corresponds to the width of the front, really. The height is associated with the object's top to bottom. So we could dimension the height not on the top view over here. That wouldn't work. It could either be on the front view here or on the right view here, and in this particular case, the height is chosen to be on the the right view. Finally, the depth is associated with the object's front to back. Now, which of these three can't we do front to back? Well, I think it would be this guy, the front view. We can't tell front to back. We could use either the top view or the right view, and it looks like the right view was used here. So this 5 inches, 5 units, corresponds to this distance here. Okay, let's take a look at this one. So if we have this object here, our front view would look like that. There's no features in the front view, it's just a sort of a sliding board. If we go to the right view and look in this direction, we're going to see this, because there's this edge right here. And this area let's see, right here corresponds to this. We can't really tell that it's slanted by this view here. We would get that information from the front view. So that's why we need multiple views, among other reasons. Okay. And the top view, again, is going to just appear as 2 rectangles with an edge here. And we're not going to really tell that this part refers to a slanted area right here, this part here. Okay, here's an example of a structure that we may have made before, and if you just think about it for a minute, you can see that the front view usually is always going to come from this direction. So you can see the front view there. The right view, convince yourself that it would look like this, with these lines here corresponding to the, actually, that one and that one. And then the top view, hopefully you can convince yourself that if you're looking straight down here, this is what you'll see. I'm going to just leave these off for a little while. And the bottom view is the only one to take a look at. We won't use the bottom view very much at all. But you can see it has hidden lines here and here. So if we're looking straight up from the bottom, we're not going to be able to see these edges here, right there. Let me get a different color. Those edges right there. Okay, so here's, we've talked about the front view many times and how important it is. So it's the one that's going to have, among other things, the fewest hidden lines and the most stable and natural position. Not completely obvious that this front view is it's a slam dunk that it's the right one, the most stable and natural. But, it's chosen here. In this particular case over here, for this object, to me, it's overwhelmingly clear that this is the right front view, in spite of the fact that we do have some hidden lines, which we generally don't want in the front view. To me, this looks like an L, and if we were to do this, we would use this one here as our front view, then we would, I think, not get the true essence of the part, nor this one. Okay, here's a question. Each of the blocks at the right has the same overall dimensions and color. By dimensions, they mean, say, here and here, and here and here, for all of them is the same. What else do they have in common? Let's take a look at all the 3. So we're doing multi-view sketching. That means 2-dimensional views, 2-dimensional sketches from many different directions. Typically, we'll use a front, a right, and a top. So I'll leave it to you to figure out what these things all share in common.